Welcome to the Drillbotics design video. This year's team consists of 5 petroleum engineers, with members namely Akita, Forrest, Savannah, Peyton, and Monaco. Dr. Ramadan Ahmed is our faculty advisor. This video is split into 4 main parts. First, the safety portion. We talk about our auto rig design. Next, the modifications made to this rig design. And finally, the new BHA design for this year. As always, safety is a key component of our engineering process. We constantly work hard to eliminate, substitute, engineer, and control hazards that may be present in the rig environment. Also, the use of personal protective equipment is a must. Following these simple criteria ensures that all team members are comfortable and safe while working. This year's team is using the same rig design from last year. It features a cantilever system, which allows it to lay down horizontally to be moved easily and has a height of 110 inches in its full drilling position. For a complete closed control systems design, the rig utilizes 8 sensors. The first is the distance sensor, based on a laser module that measures the distance traveled by the traveling block during the drilling process. The second is a torque sensor to measure the torque produced by the motor on the drill pipe. Next is the axial vibration sensor used to measure the vibrations experienced by the traveling block. We also have the RPM sensor, a load sensor to measure weight on bit, a pressure sensor, and a flow meter to measure Mars circulation systems.
New additions to the rig this year include a safety light to indicate when power is connected to the rig, Lexan to contain the rotating assembly above the rig floor, and a new Kelly hose made of pressure washer hose with quick disconnects. For the 2019 competition, with a focus on directional drilling, our team decided to evaluate different methods for transmitting power to the bent motor while sliding. The consensus was to use a cable to transmit rotation from the top drive to the bit. To accomplish this, while still maintaining the functionality of the original rig, a 2-inch thick aluminum plate is attached beneath the rig floor to accommodate a swivel bearing and threads for the male portion of the 2-inch cam lock. The female portion of the cam lock will be attached to the drill pipe. The cam lock houses the spider, which screws into the original outlet for the drill pipe. The spider rotates while still allowing fluid flow through it. A square cable slides into the spider and transmits rotation to the BHA. After the 7-degree bend in the bent portion of the BHA, the cable is attached to the bottom spider, which allows the fluid flow to be reintroduced to the rotating assembly that attaches to the bit. A 1.25-inch bearing is used to stabilize the rotation, while a brass piece held captive by Allen set screws is used to keep the BHA from coming apart under tension. To steer the bit downhole, azimuth and inclination readings are provided by our 8th sensor, which is a gyroscopic sensor attached to the BHA. To adjust azimuth and inclination, the entire rig will be placed on a frame and autonomously rotated on a 46-inch bearing located beneath the frame, with the rock orientated in the center of the bearing. An electric motor with a wheel adjacent to the bearing will provide the power necessary for rotation. Because we are consistently sliding with a bent motor, rotating the rig will switch the direction of the bit downhole.
This year, the team will attempt to incorporate an AI module in its controls. If successfully done, this will allow for predictions of drilling parameters to be compared to real-time drilling measurements, so as to give an idea of how efficient the rig is operating. This system will use algorithms based on probabilistic mechanics to progressively improve predictions on the rig performance while drilling.
Good. That's all we need.